Hello students, welcome back to Mathis Java programming tutorials. In this video, I'll explain bubble sort on one-dimensional array. Let's see the contents. Introduction, types of sorting, bubble sort algorithm, program as well as dry run, bubble sort program in the Java environment, and let's start. Sorting refers to arranging the elements of an array or a data structure like linked lists. Now, unsorted integer array like 43, 5, 2, 21, this is unsorted. Double data type array also has 12.5 at the end, almost at the end, whereas 43.5 at the beginning. And string array also Raghav, Manas, Arvind, Bhushan. Arvind should be at the beginning and Raghav should be at the end. This is what is arranged in ascending order, maybe in ascending order. That is, smaller elements at the left side and larger elements towards the right side. Can be in descending order also, that is 90, 89, 56, and at the end 2. Now, strings are sorted according to their Unicode value and requires the usage of compared to function, which we have discussed in binary search, and all primitive types use less than or greater than operators for comparison and swapping. Now let's start. Types can be bubble sort, selection sort, insertion sort, quick sort, heap sort, merge sort, bucket sort. So many types of sorting is there. But very first algorithm, using computers, data is arranged in either or ascending or descending order is because of bubble sort algorithm. So let's learn little bit about bubble sort algorithm. It is very simple algorithm, but it works very slow because of the number of swaps required to arrange the data in order. Let's see what is swapping and what is the algorithm. In bubble sort, adjacent elements are compared first of all. If required, they are swapped using a loop. Now, this algorithm requires two loops. We will understand why. In this slide, we will use only one for loop to swap the elements. Swap program, which I have taught you in lesson number 34. We will understand in this also, but elaborately it is discussed in lesson 34. Link is given in the description box. Now, if you see the code for int k is equal to 0, k less than n minus 1, k plus plus. This is inner loop we are talking about. Now, in the inner loop, if num of k greater than num of k plus 1, k is initially 0, num is the array, num of 0 will give us 43. If it is greater than num of k plus 1, temporarily k is incremented. K is 0, k plus 1 would be 1. So num of k plus 1 refers to num array 1 index. So if condition is checking, if num of k greater than num of k plus 1, that is 43 greater than 5, then swap. Swap means 5 should come in place of 43 and 43 should come in place of 5. If you see the array below the code, 5 and 43 are swapped. Now these array changes are permanent. We no longer see this particular array. We see this array only. Now k plus plus, k becomes 1 and k plus 1 temporarily becomes 2. So 1 and 2 indices elements are compared. That is again 43 and 2. Is 43 greater than 2? Yes, immediately swap. 2 and 43 are swapped. Now k plus plus. So 43 and 21 gets compared. See the below this array. Is 43 greater than 21? Yes, swap. So 21, 43 are swapped. Again, 43, 56 are compared. Is it greater than no swapping? Then 56, k plus plus. 56 greater than 89, no swapping, 5 k plus plus. Is 89 greater than 90? No swapping. Is 90 greater than 9? Yes, so swap. Is 90 greater than 12? Yes, swap. 90 greater than 14? Swap. So, len minus 1 less than len minus 1. Len, whatever is, len minus 1 is 9. Less than means 8. So, till 8 it tries to swap. If you observe, the array is not sorted. So, we need a nested loop. First thing. Second thing, array changes are permanent. And third thing is the highest element is bubbled up. Bubbled up means goes to its own position. 90 is the highest element, goes to its location, last location. We can use less than operator for descending order here in place of greater than. If at all less than, then only swap. We will see this little later on, descending order. But let's understand the points. Sorting requires a nested loop. The changes made to the array by the sorting algorithm is permanent. The largest element in ascending order or the smallest element in descending order bubbles up, means goes to its own position. Then let's see the program. Array is num. 5, 4, 3, 2, 1 are the elements. N, that is length, number of elements, is 5. So, if you see n is 5 and we are using a condition j less than n minus 1, k less than n minus 1, means n is 5, n minus 1 is 4, less than n minus 1 means 3. Starting from 0 to 3, outer loop j less than input size, that is 5, minus 1 means it works for 4 times, 0, 1, 2, 3. Then the inner loop for int k is equal to 0, k less than n minus 1, k plus plus. Inner loop k less than input size minus 1, that is 0, 1, 2, 3. But if you remember, recall the nested loops, which I have taught in lesson number 25. Link is given in the description box. For each iteration of outer for loop, inner for loop works these many times. That is 0, 1, 2, 3, 4 times. When j is 0, k works 4 times. Kth loop works 4 times. When j is 1, kth loop 4 times, and so on and so forth. So, 2 for loops, 1 if, 3 swap statements. Swap lesson 34 I have explained. Link is given in the description box. Now, if num of k greater than num of k plus 1, then swap. We'll come to swap part a little later on. But 2 for loops, 1 if, and 3 swap statements, bubble sort program is complete. Now let's see the iteration 1 of outer loop, that is j is 0. Original array is 5, 4, 3, 2, 1. And for int k is equal to 0, k less than n minus 1, k plus plus is the inner loop. And if num of k greater than num of k plus 1, that is if 5 greater than 4, then swap. So swapped and the new array is 4, 5, 3, 2, 1. And again it's 5 greater than 3, swap. Then 3, 5, 2, 1. Is 5 greater than 2, swap. 5 greater than 1, swap. In the first iteration of the outer loop and all iterations of inner loop, 5 has gone to its position. Now, iteration 2, that is outer loop, j is 1. array is changed 43215. Now again 4 greater than 3, yes, swap 3 4 are swapped here and stored. K is 1 here, so k plus 1 would be 2 0 1 2. So if 4 greater than 2 swap, so 2 and 4. 4 greater than 1 swap. 4 and 5 came to their locations. So far 7 swaps over here. Then in the outer loop, third iteration, j is 2. Again, starts from beginning. Is 3 greater than 2? Yes, swap. 3 greater than 1? Yes, swap. 3 greater than 4? No, no swap in this position. No swap. 4 not greater than 5. So far around 9 swaps have happened in bubble sort. Then comes is 2 greater than 1, fourth iteration of outer loop and all iterations of inner loop. 2 greater than 1, yes. So swapped. But if you see these orange colored ones, 2 is not greater than 3, 3 is not greater than 4, 4 is not greater than 5. In the second, k is one iteration of inner for loop only, the whole array is swapped. But still it works so many times. So we will see optimized bubble sort program in the next video. But this way, the array is finally sorted. And bubble sort program, only swap part we will see here. But program is for int j is equal to 0, j less than n minus 1, j plus plus. For int k is 0, k less than n minus 1, k plus plus. If num of k greater than num of k plus 1, then temp is equal to num of k. Num is this array. K is 0 initially, k plus 1 temporarily 1. Num of k should be stored in temp address. So temp has 5 now. The next statement, num of k is equal to num of k plus 1 equals to operator, assignment operator. Before assignment operator, it talks about the address, and after equals to, it talks about the value. So in num of k area, that is in this address area, store whatever is there in num of k plus 1. So after this statement, array looks like 4 4 3 2 1. But last statement, num of k plus 1 area, that is 1 index, store whatever is there in temp. So the array is like this, 4 5 3 2 1 instead of 5 4 3 2 1. This is true for all iterations of inner for loop. Swap. Okay. Now let's see the program in the Java environment. Bubble sort integer program. Two variables, integer type array, integer type temp. These are two important things. If the array is integer, then temporary element should also be integer. Had it been double, temporary should be double. But length will be integer, j, k indices, so they are integers. Now let's see main method. Since these two are instance variables, print is an instance method, sort is an instance method. In order to call in a static method, we create an object of the same class. So bubble int b1 is equal to new bubble int. Array before sorting is the message. b1 dot print. Print's function called 5 43 34 2 1 would be displayed because sort program permanently changes the array. Now array after sorting b1 dot print. So sorted and then printed. This program is very simple. Two for loops, one if condition. For loop can execute one for loop, so no block required. The inner for loop executes one statement definitely, so no block required. But if has three statements, so curly braces over here. Let's execute and see the program. So array before sorting 5, 43, 34, 2 and 1. After sorting in ascending order 1, 2, 5, 34, 43. What if we change just one symbol, that is instead of greater than we give less than in the if statement. If at all smaller element, then swap. So smaller elements will go towards the right. Okay, let's execute the same program again, but this time descending order. Okay, 5, 43, 34, 2, 1 is the original array, but 43, 34, 5, 2, 1. This is the descending order. Bubble double is another program. Here, double is the array, double data type array, and double temp. This is very important. Had it been character, character, and character, string, string, and string. Okay, this is the array, static void main, and b1 new bubble double is the object we are creating array before sorting. b1 dot print, b1 dot sort, and b1 dot print again. This is same program, but data type is double. Let's execute and see. Okay. See 3.5, 5.5, 10.9, 29. This is in ascending order. Had it been less than operator, it will give descending order. Okay, refer chapter 7 of Essentials of Computer Applications for further understanding and practice exercises. And the next video is about bubble sort on strings. Thank you.